Hello everyone, welcome back to the channel. So let's understand Kubernetes architecture at a very high level. So what does Kubernetes architecture consist of? So at the high level, if you just look at these two parts, okay, just look at these two parts. What the Kubernetes will contain is the control plane, which is also called as a master node. Okay, so this is the control plane, and then there will be a worker node. There will be multiple worker nodes. Okay, so your worker nodes basically will have your application and containers, and control plane is something where the whole management or the orchestration thing will happen. It is like the brain of Kubernetes. So these are the two major parts of Kubernetes architecture. And then obviously we'll have the external integrations or the user and the access part where the clients, there could be multiple kind of clients, where basically it could be a developer or a user. Then we will have the CLI, okay, and then we can have on the UI part which will communicate with the control plane, and control plane will basically uh, give the details back to the uh, client, okay, and do the activities based on the using on the worker nodes, etc. So this is how the high level architecture of Kubernetes looks like. Now let's understand few things in detail. So what does the control plane contains? Okay, so the first part is kube API server. Now this is the bridge basically between the client and the worker nodes, okay. So whatever information that you want, okay, everything happens via the kube API server. So kube API server you could say is the bridge between the client and the Kubernetes. Okay, so this is going to act. This is going to find all the information, or it can actually trigger the other processes. So when user is interacting with the Kubernetes control plane, basically, so it is via this kube API server. So everything, whenever even when you type a kubectl command or a CLI command, right? So everything goes to first goes to kube API server. Your authentication, authorization, etc. will happen, and then based on whatever uh, activity that you have asked for, that will be taken care. So this is your front end of the Kubernetes control plane. This is like the controller part of your Kubernetes control plane, and it exposes the Kubernetes API. Now the next important part is etcd. Okay, so this etcd is nothing but the key value store of all the cluster data. So it will store all kinds of data about your cluster. Okay, say suppose when I say that, okay, my number of pods, or my number of containers for a payment service or any microservices like 3, the desired state is 3, etc. So all this kind of information is stored here. So just note that this is where all the key value store, etc., all the cluster information will be stored here in the etc. And then we have a kube scheduler. So this kube scheduler is basically, see, when I create any pod, okay, so when I create any pod, so those have to be placed in one of the worker nodes. So when I say worker node, these are again physical, you could say some instances which are running, and inside those instances, I'm going to run the containers. So it has to place actually these containers in one of these worker nodes. So we might have n number of worker nodes. Okay. So just understand one more thing. When I say worker nodes, basically this is where your containers or your pods would be executed. Okay. Just note that this is where your pods and etc. will be executing. So this is where your developer basically the maximum interest of the developer is in the worker node, if you say. So so who does that actually, that scheduling part, or basically where and into which pod, basically into which node the pod is placed. Okay, so this is done by kube scheduler. So whenever a new pod is created, the kube scheduler will actually select the best node for the pod. So when we say best node is basically, say I might have 5 or 6 worker nodes. Okay, so maybe 1 or 2 worker nodes are already actually they don't have any more I mean the memory limit, etc., is already consumed by the other pods. So obviously it will not go into those worker nodes, right? So it will actually find out which worker nodes has the capacity to actually place this particular pod. That is one part. The other part is also you can have certain kind of conditional configurations, right? I might say that, okay, if the node is marked as say like it is marked for database, or it is marked for application service, something like that. So only go into those particular node only, deploy my pod only in those nodes only. So all those kind of things are taken care of with kube scheduler. So just keep this thing in mind. So when we deep dive into these concepts of Kubernetes, you will understand this. But just understand that who will place the pod into which worker node is taken care by the kube scheduler. Now the kube controller and manager comes into picture. So here, uh, see, I might say that I need to run 4 or 5 number of instances of a particular service or a pod basically when I'm creating our containers. So who is doing that. So that this is done by the kube controller and manager. So your replication, your endpoints, and all those kind of things, so that the cluster is as per your expectation, is taken care by the kube controller and manager. Okay. And this cloud controller and manager, basically this will be the service when you have the external integrations of the cloud providers like AWS, GCP, Azure, etc. So when you have certain these kind of external integrations, this is where the cloud controller manager will come into picture. Otherwise, this is an optional kind of service. Say suppose you are not integrating with any other cloud provider, etc., then this will not be in the picture. Otherwise, you will see that this is in the picture, because it has to integrate with the various services provided by the various cloud provider. Okay, so like container registry could be Docker Hub, ECR. Persistent storage it could be like Elastic Block Store, etc. DNS could be Route 53, etc. So those kind of integrations, etc., is handled by the cloud controller manager. Now coming to the worker node. So like I told you, worker nodes is basically this is where your container is going to execute. Okay, your pods. So pods is the smallest unit in Kubernetes. Okay. So when I say pods, pods can have multiple containers. Just note this part. Okay. So say suppose I have payment service and I also have a log agent as a sidecar with the with that pod. Okay, with that particular container. So my payment service and log agent, they will go hand in hand. As a so my log agent is called as a sidecar container, which is like a helper container to my primary container, which is the payment service. So payment service will have the helper container log agent, something like that. So you can have multiple containers in those cases. Ideally, you might say in most of the cases you will see that a pod has one container only. So you could say most of the time one pod contains one container, but then that is not the final truth. One pod can have multiple containers. Just note this point. Okay, and there are various other patterns how you can have the multiple containers. Sidecar pattern is one of them. So just note one point: the smallest unit. So whenever you deploy any container, so it will be deployed inside this pod, and this pod is basically the smallest unit in Kubernetes. Okay, this is where your container will be executed. And then to support basically what the worker nodes will contain, the most important part is kubelet. So this is where it ensures that all the containers are running. So it will keep on checking the status, the health of the pod, and so suppose it is not in the correct state, it got crashed, etc. It will immediately report to the control plane. Okay, and once it reports to the control plane, then obviously it will be replaced with the new pod. So all those things are taken care by kubelet. So kubelet keep on checking the status, etc. This is the kind of a monitoring service you could say, and keep on checking the status of the pod and keeps back reporting to the control plane. And kube-proxy is basically your basically enabling service networking. So there is concept of service in uh, Kubernetes. Okay, so point is, see, every pod is assigned an IP address, but so suppose when I replace this pod with a new pod, okay, because it got crashed or there was an update that happened, okay, because of the deployment, etc. So obviously the new pod will not have the same IP address. The IP address will change. So in that case, how are you going to identify your basically your service or your pod? So this is where kubeproxy will come into picture. It takes care of the networking part and the load balancing part. And container runtime is basically, see, Kubernetes earlier used to support Docker, but now the container runtime has shifted to container D and CRIO. Okay, just note this point. So it is not Docker runtime or Docker daemon which you will find in as the container runtime. Now you find container D or CRIO. As far as our deployment is concerned, you don't need to worry about that. You can create a container using Docker and just deploy it. Nothing will change for you. It will execute as it is. So this was about the worker nodes, and this is the high level architecture of Kubernetes. Hopefully this will help you understand Kubernetes in much better way, as we will deep dive into various concepts and with the examples, etc., in other videos. Like I told you, the high level flow is user sends request to the API server, which is your client, or it could be UI or a CLI, etc. Then API server validates request and stores data in etcd. Okay. Then scheduler assigns spot to the best worker node. Like I told you, the scheduler finds the best worker node for their pod. Kubelet on the node runs the pod using the container runtime. So kubelet is basically running the pod in your worker node. It is making sure that the pod is running, and it also keeps checking the health of the pod and keeps checking, giving back the report also about the pod. Kube-proxy configures networking and ensures access to services. Okay, so this is you will understand about the services, etc., and the load balancing part in Kubernetes. when we discuss something like Kubernetes services, okay, and then controllers continuously monitor and maintain the desired state. So this is like self-healing. So this is your controller part, the kube controller and manager. So this is basically monitoring and maintaining the desired state. So when we say desired state, say I am saying that my payment service should have three instances. So three instances means three pods. You could literally say three pods. I want three pods of my payment service. So in that case, controller manager will make sure that it is up to the desired level. And in any case, if there is change in that, then controller manager will make sure that the desired state is maintained, etc. And self-healing part also, that if it gets crashed, then it will be replaced with a new pod. And just a few important common Kubernetes object. This is just a very high level information. Like pods, like I told you, smallest deployable unit. It will contain the containers. Deployment is basically how many number of pods, where do you want to deploy, how the deployment strategy should be. So all those kind of information you'll find in the deployment. Service is basically how are you going to access or the communication between the pods, you could say. So this is where the service will come into picture. Config map, it will show the non-sensitive information. So like a key value pairs of your environmental variables that you pass basically to your application, you can set it up in the config map. Secret information like passwords, etc., you can store it in the secret. And persistent volume is basically your cluster storage, wherever you want to store the data. So it could be EBS, it could be any other thing that you want. And namespace is basically virtual cluster. Basically, you just divide. Uh, say suppose I have like five or six services, right? Payment service, order service, inventory service, etc. So I can create different namespaces within my cluster, and I can use that namespace for each and every service. So this helps us actually do the virtual bifurcation. So this was the high level architecture of Kubernetes. Hopefully, you would have got some idea about it. Thank you so much. Have a good day.